This is GCSE Further Maths Pure. We're in Chapter 5, Differentiation, and we've just moved on then to 5.10, Applications of Differentiation and Optimisation. So differentiation can be used to find maximum and minimum values. Make sure the value that you want, maximum min, is the subject of the equation. Use substitution if necessary to rewrite the equation with one unknown before differentiation. And let's take a wee look then at example 1. So these can be quite tough. An open tray is made by cutting 4 equal squares from the corner of a large square of cardboard 6 meters by 6 meters and then binding up the sides. What is the greatest capacity that can be achieved? So it's effectively an open box we're making from one flat sheet of card that is 6 meters by 6 meters. So here's what we have to do. A wee diagram should hopefully help us. So this is 6 meters by 6 meters. So that's 6 meters, and obviously that's 6 meters as well. And if we cut corners off and fold up the sides, I hope you can see how that makes our box. It's an open box, that's what it says in the question. So we're going to fold up these 4, we're going to do 3 folds here and then fold up, and that makes the box. Depending on how big you cut the corners, say we do a wee tiny corner, then obviously you would have a very kind of flat looking box, but if you cut out big corners then it's going to be a deeper box, and we're going to call this bit then x, and try and work out then what the optimum x is. So whenever we fold this up, it's going to look a bit like this. Let's see how my 3D drawings are looking. And let's try and work out our sides here. So this here we've folded up, that height then is going to be x. I don't know if you can see that. And then what about these sides? That's going to be this distance here. So that's 6. Take away an x, take away an x. So that's 6 take away 2x. And 6 take away 2x. So if we were to work out the volume, we would do this times this times this. So our capacity is the same as our volume. And volume is then L, B, H. So our volume is then 6 minus 2x upon 6 minus 2x upon x. Using FOIL to multiply this out would give us 36. Inner is minus 12x, outer is minus 12x. So that's minus 24x plus 4x squared. And I need to put a bracket around that then to get my x. So my volume is 36x minus 24x squared plus 4x cubed. We're trying to find the greatest possible volume, so that's what we're going to have to differentiate then. Greatest volume going to be our maximum volume, i.e. we want to find the turning point for V. We then find dV by dx. So we're differentiating this, so it's going to be 36. 24 times the 2 is minus 48x plus 12x squared. At turning point, dV by dx equals 0. So we're going to go 36 minus 48x plus 12x squared equals 0. This all divides by 12, so that's going to give us an x squared. I've changed this round as well just to rewrite it. Minus 4x plus 3 equals 0. Factorizing gives us x minus 3 and x minus 1 equals 0. That gives me two values. It gives me x equals 3 and x equals 1. Hopefully you can see that 3 can't be done. So if I set x to be 3, so that's the bell there, if that's 3 then there's no box. Does that make sense? So if that's 3, that would be 3, so that would kind of take up the whole box, and 3 would just kind of work. So we're going to write beside this one. It's going to be impossible. And so we're going to do that one. So you just can't make a box out of that. So we think then x equals 1, so we need to find out then if that is a maximum. And the way we do that is to find d2v by dx squared. That gives us minus 48 plus 24x. When x equals 1, d2v by dx squared equals minus 48 plus 24 upon 1. That gives us minus 24, which is of course less than 0. Therefore, it is a maximum. So we're there. The question has asked us for the maximum capacity. i.e. we need our value. So I mean, if you could really think it through, it's not really too tough anyway. You might need to substitute this in, but I'm just going to substitute 1 into this, so we'll see. So at x equals 1, v equals 6 minus 2 upon 1, 6 minus 2 upon 1 upon 1. 6 minus 2 obviously gives me 4. 6 minus 2 gives me 4. 4 times 4 times 1 gives me 16. And we're in meters.